So our next question. It's asking us to find out the value of tangent 60 degree. Let's copy down the diagram first. So we got a triangle, right triangle, XYZ. 21, 42, 30 degrees, 60 degrees. Right. So first, before jumping to these questions, I would like to first recall some formulas we always use in trigonometry. Right. So the first thing I'll be talking about is the SOHCAHTOA. SOHCAHTOA, which is simply stands for sine, cosine, and tangent. So for sine is equal to opposite over hypotenuse. So that's where the SOH comes from. And for cosine, it will be the adjacent over hypotenuse. And that's where the CAH comes from. And for our last tangent, we have an opposite over adjacent. Right. So by knowing this, I'll be introducing the basic model in trigonometry, which is this triangle here. Let's see XYZ. Yeah. So this is the basic model in trigonometry, and remember, as long as it has a 30-degree angle, a 60 degrees angle, and a 90 degrees angle, its hypotenuse is always 2, and the two other side will be √3 and 1. And noted that we can always multiply each side by some number, while the right triangle maintains the same property, which means it maintains its same angle. I'll write it down here. Multiply each side by some number. The right triangle will maintain the same property. Right. So in other words, if we times each side by 2, we'll have 2 plus 2 is 4, 1 plus 2 is 2, 2 plus √3 is 2√3. And we call that 1. Yep. And in this case, since we times each side by the same number, in this case will be 2, so we still have the same angle, which here will be 30 degrees, 60 degrees, and a 90 degrees here, right? So by knowing this, we can move to our actual problem. So we need to solve for tangent 60 degrees. So let's use the TOA relationship. Recall TOA means tangent 60 degrees is equal to opposite over adjacent. So we already have the value for our adjacent side. I'll copy down the graph. Yeah. So now, since it's asking for the tangent for the 60-degree angle, we only focus on angle x, right? So we already have the value for our adjacent side, but the value of opposite side is missing, which means we're missing yz, the length of yv, right? So we apply the Pythagorean theorem. I'll write it down here. Apply Pythagorean theorem, which is, I'll just write HYP as a short form of hypotenuse. Square is equal to base square plus vertical square. Right. And now we move base to the left side, which we have hypotenuse square minus base square is equal to vertical square. Oops. And so, because we want to know what vertical is, so we take a square root on both sides. So let's a hypotenuse square minus base square. Since we root square, vertical square, so the 2 is cancelled out. So we have vertical left. And now we are just need to substitute in our known values. Substitution. So for vertical will be equal to root. We have 42 as our hypotenuse minus 21 as our base. And 42 square would be 1764, and 21 square would be 441, which is root 1323, which we can rewrite it as 21 root 3. Yep. So now we have everything we need to calculate the tangent. We can write 21 root 3 here. So we have our hypotenuse 42, adjacent as 21, and opposite as 21 root 3. So let's do the tangent. So the tangent 60 is equal to opposite over adjacent, which in this case our opposite is 21 root 3 and our adjacent is just 21. So we have our tangent 60 degrees as root 3. And I also remember when we just introduced the basic model, we can always use that to check. So the triangle in these questions is 42, 21, and 21 root 3. And our original basic model is 2, 1 root 3. So you can tell it just simply times each side by 21. So because 1 times 21 will be 21. 21 times 3 will be 21 root 3. 21 times root 3 will be 21 root 3. And 2 times 21 will be 42. So our answer is correct. And so our tangent 60 will just be opposite over adjacent. which give us root 3 as our final answer. So yep, answer is correct. Good job.